All right, if you're a developer and you've ever felt like networking is just this black box of magic, then you are in exactly the right place. We've all been there, right? Things just work, but we don't always know why. Well, today we're going to tear that black box wide open and really see what's going on inside.
This is the question that trips up so many of us. You've got data zipping across the globe through these massive undersea cables, but somehow one thing is a closed connection and another is open. How is that even possible if it's all just wires? This confusion is actually the key, and we're going to solve it right now.
The entire mystery of networking, and I mean all of it, really just boils down to one single fundamental concept. It's not about the hardware. It's about the difference between the physical world and the logical world. Once you get this, I promise everything else just clicks into place. So let's break this down. The physical layer, the actual wires and fiber optics, has no idea what an HTTP request is. It couldn't care less about your JSON payload. To the hardware, it's just voltage, little pulses of light or radio waves, ones and zeros. The logical layer, though, that's where we humans got clever. It's a whole stack of agreed-upon rules, protocols, that give all those signals meaning. So how does something as simple as a line of code, let's say you're sending the word hello, actually become one of those physical signals? Let's trace its pretty incredible journey, starting from the safety of your computer's memory all the way out into the wild. Okay, so it starts as pure information, just bits sitting in your RAM. Your computer's operating system then takes that data and wraps it in several logical layers. It's kind of like putting a letter inside an envelope and then putting that envelope inside a bigger shipping box. Finally, your network card, the NIC, does the real alchemy. It translates those logical bits into actual physical electricity or light and sends them on their merry way. And this quote just illustrates the point perfectly. Think of the internet as this one giant highway system. The physical part, that's the asphalt itself. Everyone shares it, everyone drives on it. The logical part is the road signs, the GPS directions, the addresses that make sure your car gets to the right house instead of ending up in someone else's driveway. And speaking of that physical highway, here's a fact that might just blow your mind. When you think of global internet, you probably think of satellites, right? Wrong. A staggering 99% of all international internet traffic travels through about 500 massive submarine cables laid on the ocean floor. We're talking a physical network of garden hose-sized, steel-protected fiber optics connecting the entire world. Okay, so we've got bits traveling on a physical medium, and they're being guided by logical addresses. Let's move up to the next layer and see how this all builds. This is where we finally tackle that mystery of the open versus closed connection. And it all comes down to two big protocols, TCP and UDP.
The absolute best way to understand the difference is with an analogy. TCP is like making a phone call. You dial, someone answers, you both say hello to confirm you're connected, and then you have an ordered, reliable conversation. UDP, on the other hand, is like sending a bunch of postcards. You just write them and drop them in the mail. There's no connection, no guarantee they'll all arrive, and definitely no guarantee they'll show up in the right order.
And here it is. This is the big reveal, the key insight to the whole thing. A TCP connection is not a physical thing at all. The cable isn't being held open just for you. It's simply a logical agreement. It's a tiny piece of information stored in the RAM of both the client and the server that says, hey, you and I, we're talking. That's it. It's just state in memory. So how do these two computers create that shared state in their memory? Well, they do it with a quick three-step process called the handshake. The client basically says, hey, want to connect? The server replies, sure, I'm ready. And the client sends back, awesome, let's start. That's all it takes to establish that logical phone call we were talking about. Awesome. Now that we understand that a TCP connection is just a logical agreement managed in memory, we can finally understand the real difference between application protocols that we use every day, like HTTP and WebSockets. So, the crucial point here is that both of these are just different sets of rules for using that underlying TCP phone call. HTTP is a very polite, turn-based conversation. The client asks a question and then waits quietly for the server to answer. WebSockets, though, they upgrade that phone call to a free-for-all where both sides can talk or send data whenever they want. And let me be perfectly clear. HTTP, WebSockets, it doesn't matter. They are both running on the exact same physical infrastructure. The difference isn't in the wires, it's in the words. It's just a different logical agreement about how to behave during the conversation. Okay, Let's switch gears and tackle that second big mystery for developers, Docker networking. Now, this can feel like total magic, but I promise you, it's based on the exact same principles we've just been talking about. This is such a great question, isn't it? It seems completely unnecessary. They're literally neighbors on the same silicon chip. Why can't they just talk to each other? Why do we have to create this artificial network to connect them? The answer is a single, really powerful word: isolation. The operating system intentionally builds walls between them, usually using a very clever feature in the Linux kernel called namespaces. So, by default, every container is basically tricked into thinking it's the only process running on its own private little machine.
A good way to think about it is like an office building. Each container is its own locked, soundproof office. Yeah, they all share the same physical foundation and roof, but there's no way to get from one office to another. The Docker network? That's the logical creation of hallways, door numbers, and signs that lets you leave your office and go find someone else's. It's a logical map laid right on top of a shared physical space.
So, we've gone on quite a journey, huh? All the way from physical signals up to these virtual networks in Docker. Let's put it all together now into a clear, simple mental model that you can use from now on.
This is the stack you can keep in your head. At the very bottom, you have raw physics. Above that, the transport layer decides if we want a reliable phone call with TCP or unreliable postcards with UDP. Then the protocol layer sets the rules of conversation, like HTTP's request response. And finally, at the very top, our application gives that conversation its ultimate purpose, its business meaning.
So, what's the big takeaway from all of this? It's that there is no black box. There's no magic. What feels like magic is just a series of clever, layered agreements, a little bit of state held in computer memory, and processes turning it all into bits that fly across the world as light and electricity.
And that's really the point, isn't it? Once you see the layers and you understand the agreements, you're no longer just a user of the network. You have the power to actually architect it. The magic is gone and it's been replaced by understanding. So the real question is, now that the magic's gone, what are you going to build?